Okay guys, let's look at the exam question of the Doppler effect that has the graph. Now it says here, a siren of a stationary ambulance emits the sound wave of waves at frequency of 850. So it's stationary, that means the velocity of the source is equal to 0, it's not moving, and it emits the frequency of that, which is the frequency of the source. Now it says an observer traveling in a car at constant speed. So the observer, it has a speed, velocity of the listener, but we do not know. Begins measuring the frequency of the sound wave emitted by the siren when is at distance x from the ambulance, right? So it is the listener in the car that observes that is moving towards the source now in this case. So it's traveling at constant speed. So it started to measure the frequency at a distance x from the ambulance. The observer continued measuring the frequency as it approaches and passes, and then move away from an ambulance. So the results obtained. So these are the graphs of, this is the graph of frequency of the listener versus time. Guys, as I said in the previous video, the higher frequency, there will be a higher and the lower frequency in the scenario of moving away and towards. So the higher frequency, which is 900, it was when it was going towards, right, towards an ambulance. The listener was going towards an ambulance, and then after 6 seconds there was a change there was a decrease in frequency. Then it became what? 800. So that means that this is the frequency when it was moving away from an ambulance, which is the listener. So this is the frequency of the listener while it was moving towards. This is the frequency of the listener when it was moving away, right? Now in 6.1 it says the observed frequency suddenly changes at T6. So there was a change here at T6. You can see the difference there. The change in those frequency, it's 100 hertz. Give reason for this sudden change is observed. So this reason, guys, the reason for that, this sudden change there, you can see here in 6.1, while it was approaching, the listener was approaching, while the observer was approaching, the frequency was higher, right? Was higher, and then passes was higher than, the frequency of the source, and then after passing and moves away, the frequency of the listener became lower. Listener became lower than the frequency of the source. I hope that makes sense, guys, that when it was approaching, it has the higher frequency, and then passes, and then the frequency became what? Lower as it moves away. That's why there's a change there. I was explaining the change there. I hope that makes sense, guys. Okay, 6.2.1. Calculate the speed of the car. Take the speed of the sound in the air is 340. So, guys, here, calculating, we have everything here. We have the frequency while it was moving towards and while it was moving away. And are we given the frequency of the source? Yes, we are given. So now we will calculate the speed of the car using any. So guys, in 6.2.1, so I will use towards. So you have a choice there to use towards, which is towards, it's plus or minus. You can use away as well. The frequency of the listener while it was moving towards, from the graph we got, it's 900, right? It's 900. And the frequency of the source, it's what? It's 850. It proves that it was moving away. It was moving towards, because you can see here the frequency of the listener is greater than the frequency of the source. So now the velocity of the source is equal to 0, because an ambulance is stationary, and the velocity of the listener is the one that is needed here, the speed of the car. So we need here the velocity of the listener, right? Because it's the listener that is moving. So we'll say frequency of the listener, it's V plus, because we're using towards, VL divided by V minus VS times by the frequency. Then the frequency of the listener, now we have, it's 900. So we'll substitute 900 there. 900, and then the velocity of the speed of the sound in the air is 340. It's 340 plus the velocity of the listener, that's what we want, 340, minus the velocity of the source. The ambulance was stationary, and then the frequency, and then the frequency of the source, it's 850. We're told in the statement, right? Let me remove these brackets. Yeah, then what are we going to do? So we have 340 plus VL here, and then we have the 850 times in there, and then we have 340 there, and then we have 900 there. Right, I hope now we can see that it's all about maths now. So what are we going to do? The easier way is to what we can do other than cross multiplying. Okay, let's cross multiply. I think it'll be 850 times 340 plus VL equal to 900 times by 340, and then we divide by 850 both sides, 850, then that and that cancel. So we'll have 340 plus VL is equal to 900 times 340. I like to keep the answer like that, guys, instead of calculating. And then I transpose to that side, so I have VL is equal to, just duplicate this. And then what I'm going to do, I'm going to minus the 340 there. So if you punch that in the calculator, you have the answer that is 20 meters per second. Even if you were using away, guys, here you use the plus, the minus, and the plus here. You have the 800 here and then 850 there. It will give you the same answer, which is 20, right? Now 6.2.2, it says the distance x, calculate the distance x between the car and an ambulance when an observer begins to measure. So doing that, guys, we can use the equation of motion. So it's 6.2.2, because we have the initial velocity, which is 20 meter per second. The final velocity, because we're told it's moving at constant velocity, the final velocity is still what? 20 meter per second, because if it's moving at constant velocity, the initial will be final. The initial will be equal to the final, which is 20 meter per second, right? And then the time it began, we were told it began, the time we were told here it's 6. So it began to measure, or it began to no, not to measure. The transition took 6 seconds. So while it was moving towards the car, it took what? 6 seconds to pass it. So the time we have it there, it's what? It's 6 seconds. It's 6 seconds. And since it was moving at constant velocity, the acceleration will be 0. So we'll say here, we'll use the equation that says change in x is equal to vi, change in t plus half at square, right? The displacement is the one that we want. We wanted the distance x. They say calculate the distance x. So when we substitute here, we'll substitute x. So say x. And then the initial velocity is 20 and the time is what is 6 plus half. The acceleration is 0 and the time is what is 6 square. So this side will be 0. So the distance between the two, 20 times 6, it's 120 meters. So it was 120 meters away from that. I hope, guys, that makes a perfect sense. Cheers, bye.